We are Team LTI Refrigerator, and our project was audio style transfer for cover song synthesis. So the problem, there have been great advances in style transfer for images, but fewer advances in audio data due to its complicated inter-channel dependencies. After decoupling voice and music, can we apply style transfer techniques to create compelling cover songs? The current state of the art is Google actually released a project about a month ago, which is very similar, called Jukebox, which is based on VAE.
Since this is a non-standard task, we had to prepare and curate our own dataset. For this, we went over 3 iterations, which ties in closely with our outcomes, as you will see later. In the first iteration, we used 4 artists and 4 songs each, with the vocals separated and pre-processed by Spleeter. In the second one, we did away with Spleeter and used the studio a cappella versions directly, again for 4 artists and 4 songs. In the last iteration, we only used 1 song for each artist, which was also hand cleaned to make sure that the data distribution was uniform within a class.
So we pre-processed with Spleeter, which supports a bunch of different ways of splitting music into different tracks. So we took the most basic one, which is separating it into the vocals and the accompaniment. You can see an example of one of the more complicated Spleeter things on the right.
For the voice conversion, we used the StarGAN VC, which is a conception of the StarGAN specifically for voice conversion conditioned on the target output. The main difference is its use of a domain classifier in addition to the generator and discriminator. Additionally, the generated outputs are subject to a domain classification, a cycle consistency, and an identity loss to ensure sharpness of the outputs. So now I'll be taking you through 3 iterations of our problem, with variations mostly in the data as well as the hyperparameters weighting the losses of the GANs. The first iteration used the dataset generated through Spleeter and contained 4 artists with 4 songs each. The identity mapping sounded as follows. And an example class conversion output. As you can see, these results were quite poor. In the identity conversion, you couldn't even make out the words. However, you could tell that a slight tune existed. In the case of the class conversion, it was even worse. It just sounded mostly like noise at a different pitch. We diagnosed this as a result of the noise inherent in the vocals generated by Spleeter, as well as an inappropriate weighting of the GAN losses. So in the second iteration, we re-prepared our data to use studio a cappella versions directly. In addition, we also reweighted the losses to increase identity loss and cyclic loss. These results sound like and the conversion we found that noise was much better in this iteration, probably due to the data. Also, the words could kind of be made out now. However, we were still not happy with the quality of the conversion, and we hypothesized that this might be due to having multiple songs for each artist. So in the final iteration, we only used 1 song per artist manually cleaned to remove any noise and alternate sounds. This sounded like you can hear these results weren't as good as what we had expected. However, they were much better than what you heard in the first iteration. In particular, we learned that slower songs perform better, male to female or female to male conversions also perform better, and data which is small and more uniform within the class also has better conversion. With respect to the training graphs, we found 2 very interesting things. The first circle that you see corresponded to us changing the weights of the loss and led to much improved results, while the second one led to the results all sounding the same, i.e. mode collapse. Overall, though we didn't get the results that we wanted, we feel that we learned a lot about GANs and their training procedures. First being that the quality of the data in the dataset matter a lot. Any noise or skew in the data greatly affects the output. Second, that the StarGAN is very sensitive to hyperparameters, and that these need to be tuned not only between runs, but also changed and tweaked during runs based on the results, since it's very difficult to tell how well a GAN is doing just by looking at the losses. And lastly, that in any end-to-end task, what goes around the DL model affects the output a lot. We believe that we could have improved our results further by experimenting with the vocoder and feature extractor for moving between raw waveform and MFCCs. So that was our project. Thank you for listening, and GANs are really hard to train.